Friday or Thursday we were talking about sequences. You guys remember geometric and arithmetic sequences? What does arithmetic sequence mean? They kept adding the same value over and over. It might be a negative value, but and the added value is called the difference. And then the geometric sequence had a multiply value that was used over and over. Sometimes the multiply value was like a fraction, like 1/2. It's kind of like dividing by 2. But and then we had other sequences that didn't really fit either of the categories, just kind of whatever. Had exponents or multiple things going on. So we're kind of doing the same sequences thing today, but we're talking about writing them differently. I don't think I mentioned this, but the way that we wrote them on Thursday was, they call it explicit, where they just use the n for the nth term. So we put like zoom out there. So if it was an arithmetic sequence, you want to like remember how I said, like if it's, let's say it's 2, 5, 8, 11. So the pattern is +3, but we kind of started back one term and then we did like +3. And so that's an example of an arithmetic sequence of adding 3. Okay, this is called an explicit statement. What we're doing today is writing it recursively. So it's a recursive function. And it looks, well, the first part kind of looks the same. It's got a t of n in it. You could write the same sequence like this. I think it's a little more intuitive, I guess. Okay, what's going on with this n and n-1 thing? So, well, actually, usually they start with like the 0th term is, like the starting term is 2. And then actually they're using t of 1 on this one. Sometimes they do t of 0. The starting term is 2. So if I want to know what the second term is, it's basically, I want to know what t of 2 is. That's going to equal t of 2 minus 1 plus 3. So t of 2 minus 1 is just t of 1. See what it's saying? So the second term is equal to the first term plus 3. Or if we plug in a 3 for n, what's t of 3 equal? Well, that'd be equal to t of 3 minus 1, which is the second term, plus 3. So whatever term you're looking for, this is going to stand for the term that preceded it, that came right before it. So if this is the 5th term, this is the 4th term. So it just takes the preceding term and does this to it, plus 3. That kind of makes sense? So it just keeps adding 3 over and over. But the only difference is you kind of have to say where are we starting at if you do recursive. Unlike the explicit, where you just you start with n equals 1 and you plug it in there. By the way, you can still have n's in here. Like if I did that, what would happen is like the second term, this would go up by 6, and on the third term, this would go up by 9, and on the fourth term, so you can still use n as a variable, not just as a term counter. You all right? I think this one's kind of straightforward. It might take a little bit to get used to it, but I don't think it's super crazy. So we're on page 481. some reason the directions say find the third, fourth, and fifth terms of the sequence. So I guess, I don't know. I don't know why they didn't ask for the second term. But what is number one? What's the pattern going to be? It's just a +4. It's a arithmetic sequence. It's just going to keep adding 4 to the previous term. So if the first term is 6, t of 1 equals 6, the second term is going to equal the first term plus 4. So the second term is 10. They didn't ask us to write that one down for whatever reason. So the term after that will be 10 plus 4. So it's 14. And then the next term will be 18. And then the next term will be 22. So those are the terms at once. 3, 4, and 5. Okay, on number 3, the first term is 1. So this one, if you look over on the right, it's 3 times t sub n minus 1. So it's just going to do 3 times the previous term to get the next term. So if the first term is 1, the second term would be 3 times 1, 3. Next term will be 3 times 3, 9 times 3. 27 times 3, 81. Just uses the previous term times 3. Number 5. What's happening on this one? Well, it's adding 2. It's kind of, I talked about this a minute ago. It's adding 2 times whatever number the term is. But it's 1 less than that. Okay, so anyway, if we plug in, if we want to find t of 2, we're going to use t of 1 plus 2 times 2 minus 1. Let me write this one out. This might be a little confusing with all the different ends all over the place. So, we know what the first term is. It's a 1. So if we're doing the second term, 2 minus 1, this is the first term. Plus 2 times, what goes right here? Well, n is 2. We're on the second term, so that should be a 2 right there, and a 1. So t of 1, they told us was 1. So it's really 1 plus 2 times 2 minus 1 is 4. Okay, that wasn't really an answer though that they were looking for. So the third term is going to be the second term plus 2 times the n value, which we're on the third term, so n value is 3 minus 1. So this would be 4 plus 6 minus 1 is 9. That is the first answer. The fourth term is going to be 9 plus 2 times n, 2 times 4, minus 1. 9 times 8 is 17, minus 1 is 16. These numbers looking familiar? Kind of a different pattern that would work for this. Okay, this one. So we're taking the previous term plus 2 times the number of the term we're on minus 1. 16 plus 10 minus 1, 25. So these are the 3 that they wanted. Anybody knows something special about these numbers? Yeah, they're perfect squares. 2 squared, 3 squared, 4 squared, 5 squared. So it's another way you could find squares without just multiplying the number times itself. I don't know why that works, kind of weird. Just one of those things. Yeah, perfect squares, they increase by, it's like +3, +5, +7. So they keep increasing by increasing value. Right, number 7. Okay, this one's a little bit weird because it requires the previous two terms to find it. So it says T of n equals T of n minus 1 plus T of n minus 2. So on this one, they had to, since they're using the previous two terms, they had to define the first two terms. That's why they asked for the third, fourth, and fifth, because some of them already have the second term. So the first term is 2, the second term is 4. So it needed to give us 2 to start off with. So it's just, you're basically just adding the previous two terms, 2 plus 4. 6. Now, this is not a geometric or arithmetic sequence, right? It's just it's doing a little more. Okay. Now the previous two, so that's the third term, so that is one of our answers. The fourth term is going to use the second and the third term. T sub n minus 1. If this is 4, this would be the third term and the second term. So you just use the previous two. 4 plus 6 is 10. For the fifth term, we're going to use the third and the fourth term. 6 plus 10, 16. Number 9. Okay, this one, they are subtracting and then squaring it. So it's starting with 5 and 8. This is the older term. Actually, I got that backwards. This is the older term. So if we're looking for the third term, this one would be T of n minus 1 would be the second term. And n minus 2, 3 minus 2, this would be the first term. So they told us 8 was the second. So actually it's 8 minus 5, not 5 minus 8. So 8 minus 5 is 3. Okay, so if we're looking for the fourth term, then we need to do the third term minus the second term. Okay, this one's actually closer to this one than this is. Oh, I forgot to square it, didn't I? So 8 minus 5 is 3, 3 squared is 9. Okay, on this one, the third term, which is what we just found, is 9, minus the second term, 8. It's 1. 1 squared is 1. The fifth term is going to be the fourth term minus the third term squared. So the fourth term is what we just found, 1. The third term was what we found previously, 9. 1 minus 9 is -8. Squared is 4. This one's kind of all over the map. I don't know what would it turn into if it kept going. I think it's going to start getting huge after that. So it got smaller and then it's going to blow up. Number 11. Okay, find an explicit definition for the sequence in exercise 1. So explicit is what we did on Thursday. It doesn't use the T of n minus 1, it just uses an n. So the pattern was, it was like 6, 10, 14. It was a +4 pattern. Alright, so it still starts with T of n. We just are not going to use T of n minus 1. Alright, I talked about this at the beginning. How did we start on Thursday? We backed up one step from the first term. So if the pattern's +4, -4 backwards, so we're going to start with a 2. And then we're increasing by 4 per term. term, sort of. So that's the explicit. Number 12, of course, goes with number 2. It's writing the geometric in explicit form. So you have to back up and then you guys remember how we did that? Like if we had a times 2 geometric like this, so you back up by dividing by 2, so it's like 2.5, and you do times 2, maybe parentheses, and then that happens n times. That's what a geometric term looks like, explicit, like the variables in the exponent. All right, anyway, 13. Okay, we're writing the recursive formulas ourselves. So what is the pattern on number 13? It's a +4 pattern again. Actually, before I do that, we should go ahead and say what the first term is. The first term is 9. Okay, and then the pattern is +4. So that means it just takes the previous term and adds 4 to it. And that'll be it. 15. A little bit trickier now. 1, 3, 7, 15, 30. After you see a few of these, you kind of get an idea of how you can write them. But what's the pattern on this one? You guys see it? Yeah, it's increasing by an increasing value, a double value. 2, 4, 8, 16. How could we write that? Well, what kind of numbers? Actually, I didn't look at. Can't remember how the book wrote this one, but what kind of numbers are these right here? 2, 4, 8, 16. Kind of got their own pattern here. What's special about those numbers? They're all powers of 2. Like this is 2 the first, 2 the second, 2 the third. So we're adding powers of 2. How do I write powers of 2? Well, it's 2 to the n. So on the first term, actually, forgot to define the first term. I feel like the book wrote this one easier, but I kind of forgot how they did it. If we did 2 times the previous term plus 1. Oh yeah, that works too, doesn't it? Yeah. Okay, that one would have worked, but I think the way the book wrote it is easier. Another way of looking at it, 2 times this term plus 1 would also work. So 2 times 1 is 2, plus 1 is 3. 2 times 3 is 6, plus 1 is 7. 2 times 7, 14 plus 1, I think that's how they wrote it, right? 15. Oh no, actually they used my first answer. both work, so I don't know. I thought this one was a little more complicated. So we're adding powers of 2, but why did I do the n minus 1 thing? I never really talked about that. Because on the first term, we're not really doing anything. To go from the first term to the second term, I need the first power of 2. So for the second term, I need this to be a 1. So n, on the second term, n would be a 2. So I needed to take it down a notch to turn that into a 2 right here. It's kind of a tough one. I wonder if there's other problems that have more than one answer. Hope not, that'd make great, because the book did not write both answers. That could be a problem. Alright, 1, 3, 6, 10. Okay. What's the pattern? 10, 15. I don't know, I feel like this one's actually maybe easier. You guys see the pattern? Plus 2, plus 3, plus 4. I wonder on the evens, are they all multiplying patterns? Plus 2, 4, 6, 8. Times 2, times 3, times 4. It might be tricky to figure these out. I'll let you guys struggle a little bit with them, see if you can figure out a pattern. Well, this one just keeps adding an increasing value. So the n value keeps increasing as you go along the list. To get the second term, we're just adding 2. To get the third term, we're adding 3. To get the fourth term, we're adding 4. So really, we're just adding n, the number of the term, from the previous term. Previous term plus the number of the term. That would do it. Fourteen's pretty straightforward. 16 plus 2 plus 4 plus 6. It's not plus 2 plus 4 plus 8 like we had. Yeah, I'll let you guys play with 16 and 18 and try to figure them out. Figure out a way to get it done. Alright, 19. Give the first 8 terms of the sequence defined recursively by t sub 1 equals 3, t sub 2 equals 5. Okay, I guess on A it's just plug stuff in and figure out, and B we gotta think a little bit. So, we're doing n minus 1 minus n minus 2, so the third term, t sub n minus 1 would be t sub 2. So we gotta do 5 minus 3 to start off with. So it's like the previous term minus its previous term. So 5 minus 3 is 2. And then, so 2 is this term. So then we got to do 2 minus 5 is negative 3. Negative 3 minus 2, negative 5. Negative 5 minus negative 3. How many did it say it wanted? 8. That's a lot. Okay, so we're to negative 2, and then I can do negative 2 minus negative 5, positive 3, and then 3 minus negative 2, 5, 1, 2, 3, 4, 5, 6. Okay, and then 5 minus, okay, you guys see what's happening here? 2 minus 5. 3, 5, 2, negative 3, negative 5, negative 2, 3, 5, 2, negative 3. It's starting to repeat itself. So since they're using the same numbers, it's kind of like when you divide and get a repeating decimal kind of thing. Yeah, so how long before it starts repeating itself? 6 terms. On the 7th term, it goes back to the beginning. Anyway, that's the A answer. Okay, on the B answer, observing the pattern you get in part A, tell what the 1000th term of the sequence will be. Okay, well, what's happening is every 6, the pattern starts over, right? So if we could take that 1000 and divide it into 6, like groups of 6, that'll kind of tell us how many times it went through the sequence, through the pattern part. We kind of did something like this on, you guys remember like imaginary numbers with I squared, I cubed? It's kind of that kind of idea. So 10 divided by 6 is 1, with a remainder of 4 and 6, remainder of 4 and 6, with a remainder of 4. So kind of what this tells us is it's going to go through the pattern 166 times, and then it's going to go 4 more. Let's see, would this count as 0? Yeah, because if we divided by 6, we'd end up with the 7th term. This would be like the, yeah. So if we had 7 terms, 7 divided by 6, that'd be 1 with remainder 1. So the remainder tells us like how far we are into the next term. I guess if we got a remainder of 0, it would be the 6th term. So the remainder tells us how far we are in. So 1, 2, 3, 4. So it would be a negative 2. No, wait. I do in math error. Let's see, did I get my answer in A right? No. What did I do wrong? N minus 1, N minus 2. N minus 1, N minus 2. 3, 5. Oh, shoot. Okay. Well, I didn't get this wrong, but what I got wrong was I used this instead of this. This is the first term, not this. Okay, this is actually the 3rd term right here. You guys get it? So they gave us the 1st and the 2nd term. So what I should have been looking at actually is this. This is the 3rd term, not this is the 1st term. Okay, so the 4th term over is 1, 2, 3, 4, negative 3. Actually, instead of negative 2. Alright, we'll call that. Is that blowing hot air? I hope not.